Hello class, welcome to our lesson for the day in section 1.4 of your textbook. It's dealing with the properties of trig functions and just kind of starting with some building blocks of those things. So we're going to look at those pieces today and then probably split this up into two lessons just to make sure everyone's on the same page. The first thing that we want to look at is what's known as the reciprocal identities. These are just another way to show that like sine and cosecant are reciprocals of one another. For example, sine of theta is y over r. And if sine of theta is y over r, if you do the reciprocal of that, that's 1 divided by that number. And cosecant will be the same as r over y. So really it's just a different way to showcase the fact of the reciprocal nature of all of the trig functions. So remember, sine's reciprocal is cosecant, cosine's reciprocal is secant, and tangent's reciprocal is cotangent. You'll notice at the bottom, you'll want to make a note that sine to the -1 of theta does not equal the reciprocal. Sine to the -1 is what's known as the inverse sine. That's going to be used to solve angles as we move through the chapter. But I bring that up because typically in algebra, x to the -1 is 1 over. So that piece in algebra works, but in trigonometry it means something specific. So you want to make sure that you don't use that button, say on a calculator, to be able to find your answers. 1 over sine, okay, is just cosecant. So those reciprocal identities will be useful to you depending on the scenario and the question that's written. The other identities that you want to know really well, probably the one that's used most often later on, maybe not necessarily in our class, but in trigonometry in general, is the tangent quotient identity, which says tangent of theta is the same as sine divided by cosine. So tangent of theta is the same as sine over cosine because sine is y over r. If you look here in the middle, I tried to write some things out. Sine is y over r, and then you're dividing by x over r, and the r's cancel. So these two things cancel, and you're left with y divided by x, and that's the same as tangent. And then if you agree that tangent and cotangent are reciprocals, then if tangent is proven to be sine over cosine, then its reciprocal has to be cosine over sine. But they're strictly just basically getting rid of the r values from the denominators and canceling them out. So some of the questions that you see will actually be really easy if you understand the relationship between them. They're not going to give you a whole lot of info. So all three of these examples, what you'll notice is that whatever's given, you're looking for the reciprocal. So find secant given cosine is 1/4. That will mean that secant will just be its reciprocal. When you plug into Math Excel, you want to make sure that it's just 4. If it's a whole number or an integer like 4 or -3, you don't need to divide by 1. I think it'll count it wrong if you do that, so keep that in mind. The second one says find if cosecant is root 10 over 2. You would flip that around. Okay, so now it's 2 over root 10. You multiply by root 10 on the top and bottom to rationalize it. But then you'll notice here at the very last moment you have to simplify. So this 2 and 10 needs to become a 5 on the bottom just by simplifying those pieces. So that's something to keep in mind as you're looking at those questions. I starred the last one because it's important to make sure you understand if you get something as a decimal to not panic. The last one says given cotangent of theta is 1.2 blah blah blah, all of this decimal. If that happens, what you should do is just put it over 1. And then it's the same as all the rest of the problems. If you put that number over 1, then its reciprocal is just 1 over that, and then you can find that decimal. When you plug things in on your homework, you'll want to actually find that answer. Don't leave it as 1 over the 1.2 number. Actually find it, and it's around 0.8. But if you just see a decimal like that, it's probably not a rationalized question like the one above it. It's going to be more so of a, here's the decimal, find the decimal answer. So those are a few examples that should be easy to find based upon the fact that they're reciprocals of one another. The next thing to discuss is figuring out what the signs of all the trig functions are. We did a little bit of this in section 1.3, but I want to elaborate on it in this section. When it says the signs, it's saying is it positive or negative? So really, you're looking, are things positive or are things negative? Probably the easiest option that I think most of you will find success with is using the analogy of all students take calculus and just having this off to the side and using it to help answer your questions. What this tells you is which of the three main trig functions, sine, cosine, and tangent, are positive. So in quadrant 1, everything is positive. In quadrant 2, sine is positive. In quadrant 3, tangent's positive. And in quadrant 4, cosine's positive. Now, that only tells you the main three. You have to make sure you recognize whose reciprocal goes together, and those will also be the same sign. Those ideas work because of the way x and y interact with the coordinate plane. So whether x is positive or negative and vice versa for the y values. So in the angle 162, what you need to know is what quadrant does 162 end up in. So 162 is past 90, but not quite to 180, so it would be graphed in quadrant 2. And once you know that, honestly, the easiest option is this. So in quadrant 2, sine is positive. So you notice I have sine is positive. If sine is positive, its reciprocal is also positive. Don't get confused about the reciprocal piece, because whatever the fraction is, if it's positive and I flip-flop them, it's still going to be positive. So sine and cosecant are positive, and all the others are negative because the x values are negative, okay, in that quadrant. So cosine, secant, tangent, and cotangent are all negative. The next one is negative 380 degrees. Two things to think about. One is this goes around the circle at least once because it's at least 360. The other thing is it goes clockwise because it's a negative angle. So you go all the way around 360, and then you have 20 left over, and that puts you in quadrant 4. The most important piece is you're in quadrant 4. And that means that cosine is positive because the x values are positive. And so cosine and secant are positive, but then sine, cosecant, tangent, and cotangent are negative. The next style of question will tell you that things are greater than 0 or less than 0. Now you have to kind of think back to algebra times. We did a lot of that with things like above and below the x-axis for positive and negative. So if something says it's greater than 0, that means it's positive. If something says it's less than 0, that means it's negative. The first one says that sine is positive because it's greater than 0, and so is tangent. Because of that, it can't be any of these other spots because only sine's positive in quadrant 2 and only tangent's positive in quadrant 3. So the only time sine and tangent will both be positive is it has to be in quadrant 1 because everything's positive in quadrant 1. On the second one, you'll notice it says secant is less than 0, which means it's negative, and cosecant's greater than 0. Now you can learn a lot about secant, cosecant, cotangent, but I think there must be a reason why there's only 3 buttons on a calculator. You want to make sure you understand things with sine, cosine, and tangent really well, and that's how I typically look at them as well. So if secant is less than 0, you have to think, well, whose reciprocal is secant? And that's cosine. So if secant's less than 0, so is cosine. And that means cosine is negative. Sine then is the same as cosecant, and that means sine is positive. And the only spot that's going to happen is in quadrant 2, because in quadrant 2, sine is positive, but cosine is negative, because cosine and tangent are negative in quadrant 2 because of the x values being negative in quadrant 2. The next question asks you to use identities to solve the following trig function. Now, I will tell you that on the homework, when you're due to view an example, these questions can kind of become very cumbersome and very difficult. I want to make sure we're clear about the fact that you should really be focusing on right triangles. Okay, so given that cosine is 3 over 5, essentially what you're saying here is that x is 3 and r is 5, and it's in quadrant 4. So just draw your picture in quadrant 4 with x being 3 and r being 5, and then do Pythagorean theorem and find the missing piece, and y is 4. The thing you want to make sure of is that you make sure that y is negative 4 because it's going downward. Now, if you forget that, there's another option we'll talk about at the very end of this question. But don't forget that it should be negative 4. It says then, based on this information, x is 3, y is negative 4, and r is 5. Find sine of theta. So sine is the y value over the r value, which would be 4/5. But it's negative because it's going downward. Let's say you totally forget about the negative thing. Well, you could use all students take calculus and figure out, well, in quadrant 4, only cosine's positive, which means sine has to be negative. That's a second option that you could use, so that same device with the all students take calculus could still be used in order to find that answer being negative. The next example is similar. It's just there's some radicals involved, so you got to simplify. It's nice for you on these questions. They only ask you to find one trig function instead of all 6. That saves you a little bit of time. Well, actually, probably a lot of time as you're looking at these scenarios. You'll notice that it says it's in quadrant 3. So I drew my picture in quadrant 3 here. And it says tangent, which is y over x. Okay, so you want to really know those. Have those off to the side. Start knowing those. You'll save a lot of time if you just know those pieces instead of having to look at them constantly. So the y value is 11 and the x value is 3. Now notice here I put them both negative. Why? Because I'm going backwards and down. So the x and y values are actually negative. But when you divided them, you got a positive. Pythagorean theorem, 3 squared is 9, root 11 squared is 11. Add them together, you get 20. You have to simplify and rationalize denominators in all cases. So you want to make sure that you do that, and it should become 2 root 5. If you struggle with rationalizing, make sure you talk to me about it sometime or look up a video, because a lot of your issues you're going to run into on your homework will ask you to rationalize, and that could be part of the problem of not getting an answer correct. So keep that in mind. The other thing is r is always positive. Why? Because r represents the distance from the origin, and distances should always be positive. Think about it. You can't go negative miles driving a car, for example. I think Ferris Bueller's Day Off kind of explains that. If you don't know what I'm looking at, look it up. It's kind of interesting. Okay, this question asks you to find secant. Now, I don't know anything about secant, so I just find cosine and flip it. So cosine would be the x value, which is negative 3, over the r value of 2 root 5. Now, if you're looking at the information and you have to find secant, you could know it's r over x, and that's fine. The important thing is if you find cosine first, don't rationalize it, because you're just going to flip it. You're just going to take that answer and flip it, so there's no real point in rationalizing that question. If you're asked to find other ones, you just use the triangle, use x, y, and r. Same idea to find all of the trig functions that you would need. Okay, we'll stop there for the day. When we get back together in the next class, we're going to look at a little bit of graphing and a few other examples that I think will help you make sure you understand how the reciprocals work and how to deal with the ratios. Have a good day, everybody.